Okay, class, we're going to start Chapter 11, Section 1, Part 1. The beginning of your notes, I believe, say Chapter 11.2.2. You can make that small change right there. It's actually Chapter 11, Section 1, Part 2. We're going to be looking at recursive formulas and explicit formulas dealing with sequences. The definition of a recursive formula is as follows. It defines terms in a sequence by relating each term to a previous term. So I'm relating the third and fourth term, or the seventh and eighth term, or the n and the n minus 1th term. For example, I have a sequence 2, 4, 8, 16, 32, 64, and so forth. I want to relate the two succeeding terms. And you can see that to get from one term to the next, I'm simply going to multiply by 2. So to get from 2 to 4, I'm going to multiply the first term, 2, by 2 to get 4. To get from 8 to 16, I'm going to have to multiply that 8 by 2 to get 16. So you can see that I am relating two successive terms. A recursive formula would look like this then. A sub n equals 2a sub n minus 1. And then you have to tell us the first term you're beginning with. So a sub 1 is 2 as stated. So if I want to find the second term, that's a sub 2 then, I'm going to have to take 2 times a sub 2 minus 1. 2 minus 1 is 1, so I'm really saying a sub, or 2 times a sub 1. Well, I already know what a sub 1 is. It's 2. So I'm really taking 2 times 2 to get the number 4. To find the third term, a sub 3, I'm going to have to take 2 times a 3 minus 1. Well, 3 minus 1 is 2. A sub 2, we already know that. The second term is 4. So I'm going to take 2 times 4, and that's going to give me the number 8. And we can just proceed along the same thoughts. That's a recursive formula. Remember, the recursive formula has two parts. The part that relates two successive terms and whatever you're going to start with. The explicit formula is much like a regular function that you're familiar with. It expresses the nth term in terms of n. For example, let's look at this sequence. 6, 11, 16, 21. And if I keep on going, we get 26, 31, 36, and so forth. And you can quickly see that that sequence is defined by the explicit formula a sub n equals 5n plus 1. So that if n is 1, I will have 5 times 1 plus 1, which is 6. If n is 2 for my second term, I'll take 5 times 2 plus 1, and that's 11, and so forth. And that's the explicit formula. So we're going to be working on both of these formulas in the next couple examples. All right, we're going to look at example 3 now. Describe the pattern that allows you to find the next term in the sequence, 2, 6, 18, 54, 162, and so forth, and write a recursive formula for the sequence. Well, if we just look at the sequence briefly, we can see that to get from 2 to 6, we have to multiply by 3, and from 6 to 18, we have to multiply by 3, and from 18 to 54, we multiply by 3. So we can see the connection between two successive terms. We're going to have to multiply by 3. So I'm going to write out, or I have written out, the first 10 terms. The first term, a sub 1, is 2. The second term, a sub 2, is 3 times the first term. The first term is a sub 1, or it can be written as 2 minus 1, a sub 2 minus 1. A sub 2 minus 1 is really a sub 1, and we already know a sub 1 is 2, so it's really 3 times 2 is 6. To find the third term, I'm going to have to take 3 times the second term. Well, the second term is really a sub 3 minus 1. We already know that's 6, so 3 times 6 is 18, and we could continue the same pattern, but I'll just write the sequence out by multiplying the previous term times 3. So I've got 54, and then 54 times 3 is 162. 162 times 3 is 486, and 486 times 3 is 1,458, and so forth, simply by multiplying the previous term by 3. Now it says find the 6th and 7th terms of the sequence. Well, we already know the 6th term is 486. The 7th term, again, is simply multiplying the previous term, 486, times 3. To make a small adjustment here. That's 486, and equals 1,458. The 10th term, we already have it written, is 39,366, but I could find that by taking 3 times the 9th term. The 9th term is 13,122, and that's how I can get my 10th term by using the recursive formula. Again, remember this recursive formula has 2 parts: the part that relates to successive terms, and then the beginning value. Example 4 shows 2 sequences, the length of a side and a perimeter, and we're wanting to find the sequence for each one in an explicit formula. So if I look at the length of the side of a regular pentagon, we know the length of a side, if one side is 1, we're going to let a side for the next sequence be 2, and the next sequence be 3, and so forth. And the corresponding perimeter for that, if one side of a pentagon is 1, then the perimeter of that pentagon would have to be 5, because we've got 5 sides. So it might look something like this, where I've got 1s on each side and the perimeter is 5. But if I have 2 on each side, then clearly the perimeter all the way around is 10, and so forth. So for each sequence, find the next term a sub 5 and the 20th term a sub 20. Well, if I kept on going, I would simply say a sub 5, and that's going to have to be 5. And if I look at my perimeter, I'm going up by 5, so certainly my next value for my perimeter sequence would be 25. I could write it like I have underneath the each question. The length a sub 1 is 1, a sub 2 is 2, and so forth. And finally, all the way out to a sub 20 is 20. The perimeter, a sub 1 is 5, a sub 2 is 10, as the spreadsheet shows. A sub 5 would be 25, because I'm just multiplying each one by 5. A sub 10 would be 10 times 5, which would be 50, and a sub 20 would be 20 times 5, which is 100. So the explicit formula for a sequence for just the length sequence is simply a sub n is n. So a sub 12 is 12. Okay? The perimeter, we can see from our spreadsheet that I'm multiplying each one of those by 5. So a sub 1, or 1 times 5 is 5, 2 times 5 is 10, 3 times 5 is 15. So in order to find the perimeter, I'm going to say a sub n equals 5n. So this becomes pretty easy. So a sub 3 is simply 5 times 3, which is 15. And of course, that's what we know it should be. It matches our value in our spreadsheet. That should take care of it for this section. You have an assignment to work on. We can work on in class, and if you have any questions on this, we can finish that up in class.